All right, this is a little bit of a different look from other videos that we've done because you'll see we have 3 lessons. So all of these lessons tie to something called limiting reactant, but because these problems are so big, we're going to break it down into, whoops, I see I have a typo there. We're going to break it down into 3 separate lessons. Well, I'm not just doing a part 1, part 2, part 3, because they're actually different, kind of semi-different topics. So we're going to start off with 905, and I've got 2 sample problems. So we're going to do this application for the 2 problems, and then in 906, we'll take the same 2 problems, and we're going to apply this to it, and then we'll take those 2 problems again, and we'll finally do this. But before we get started, we have to talk about what is a limiting reactant. And as long as we're talking about that, let's talk about an excess reactant. Well, let me give you a sample. Let's say we take 1 bun plus 1 slice of meat to make 1 sandwich. So this is the simplest type of equation I could think of in terms of an everyday type scenario. So if I have 23 buns and 10 slices of meat, how many sandwiches can I make? Well, each sandwich has to have a slice of meat, so I can only make 10 sandwiches. This is my limiting reactant, so this becomes my limiting reactant. And this is going to be my excess. So if I look at, and my mole ratio here is 1 to 1 to 1. If I look at my mole ratio, I can see how much of a product I'm going to make. And this matters because if you're working in an industry, so for example, we did chrome plating. Chrome's pretty expensive, and you don't want to have a bunch of extra chrome lying around that goes to waste. So you want to make sure you have pretty close to an equal amount of the reactants that you need to produce the product that you want. So we're going to just kind of work through this with sample problems, and it's going to be conversions again. So now we're still doing our conversion spectrum, but it's what I call applied conversions. You can't just kind of slap numbers in. You have to think about what it is that you're trying to do. What is it that you are starting with and going to, and how does that apply to being a limiting and an excess? So with that said, let's kind of jump in. All right, I have methanol, CH3OH, is the simplest of alcohols. It is synthesized by the reaction of hydrogen and carbon monoxide. 500 moles of, I got another typo, 500 moles of carbon monoxide, CO, react with, should put it there, 750 moles of H2. That's the same thing as saying if I've got 23 buns and 10 slices, but now I'm doing it in moles. I have 500 moles of this, and I have 750 moles of this. Well, hopefully you notice that this isn't balanced. So if you want to practice balancing, you can pause the video. Otherwise, I'm just going to write my mole ratios in. So I have my coefficients in 1 to 2 to 1 to balance this. One of the things I like to do is jot down underneath my equation what I'm starting with. So I have 500 moles of this carbon monoxide, and I have 750 moles of hydrogen gas. And what I want to know is which one of these is going to be my limiting reactant. So we are solving for the limiting reactant. And it's going to be the reactant that I run out of first as I'm making this methanol. So when you're doing limiting reactant problems, we're going to do this with 2 calculations. You have to do 2 calculations. What I'm showing you is the 2 calculation method. There's actually a faster method. If you look in your textbook, you'll see when they find the limiting reactant, they do a comparison of these 2. It's called the comparison method. But I find that the two calculation method is what 90% of students choose to use. And it tends to be a little bit simpler in terms of understanding where you're starting from and where you're going to. The two calculations are going to be product, so we're going to call this number one. Let's do this. Number one. You're going to see how much methanol you can make with 500 moles of carbon monoxide. And then number two, you're going to see how much methanol you can make with your hydrogen. So let's start with calculation number one. So here's my, let's frame that up. So in this case, I'm going to start with, I'll just stick with my pink. So calculation number one. I'm going to start with 500 moles of carbon monoxide. I'm going to put that over 1. What am I solving for? I want to find out how much of this methanol I can make. So do I want it in moles or do I want it in grams? Moles will be faster. So let's just go to moles. So now all I'll have to do is a mole to mole conversion. So we're framing up, we're going to go to moles of CH3OH. That's going to make my starting point here, A, and that's going to make my ending point here, B. Well, because I'm going from mole to mole, I just need the mole ratio, which in this case, and I'm not going to write this out, I'm going to write it as I go because it's a 1-to-1 mole ratio. So I have 1 mole of CO to 1 mole CH3OH. And you might be thinking, I could have figured that out on my own. Yeah, but we're starting with an easy problem. So that means with 500 moles of carbon monoxide, I can make 500 moles of methanol. All right, let's do this again, but let's do calculation number 2. This time I'm starting with 750 moles of H2. I'm going to put that over 1, and I'm still going to moles of CH3OH. So because I'm going mole to mole, I just need the mole ratio. In this case, I have a 2-to-1 mole ratio. So I have 2 moles of H2 to 1 mole CH3OH. And so when I multiply and divide, I end up with 375. Remember, I'm trying to find out which one of my limiting reactants. So the reactants are on this side. If I look at these two numbers, if I start with this much, if I start with 750 moles of hydrogen, I can make 375 moles of methane. If I start with 500, I can make 500. So which one's limiting? Well, think about it. If I come back up here, I have 23 buns, 10 slices. I can make 10 sandwiches. This is what limits me. So the smaller of these two numbers is the limiting reactant. And remember, my reactants are back here. These are my reactants. So that means this is the smaller number. This means that hydrogen is my limiting reactant. That means that my carbon monoxide is going to be excess. I'm going to have leftover carbon monoxide. I have more than I need. All right, I'm going to pause the video while I change pages for the second problem. So for this second sample problem, we have the unbalanced equation for the reaction of calcium phosphate with sulfuric acid is as follows. If 250 grams of calcium phosphate react with 3 moles of sulfuric acid, will 3 moles of calcium sulfate be formed? Now this one's a little bit more advanced. First thing hopefully you noticed is that the equation isn't balanced. If you want practice balancing, pause the video and try to balance this. Okay, how'd you do? Did you get that this is a 1? This is a 3, this is a 3, and a 2. 3 calcium, 3 calcium. I've got 2 phosphate, I've got 2 phosphate, I've got 3 sulfate, and then hydrogen, I've got 6, and I've got 6. All right, so the first thing we want to do is find the limiting reactant. That's the title, that's what this video is all about. So I have to, one of the things I'm going to do to start with is let's write down, I've got 3 moles of sulfuric, but you'll notice this is in grams. My calcium phosphate is in grams. So to simplify things, let's convert the calcium phosphate to moles. So I'm going to do a mass to mole conversion. I've got 250 grams of Ca3PO42. I'm going to put that over 1. I'm going to run out of room. Yikes. Let me rewrite it over here. And I'm going to multiply that by the molar mass. So what I have to do is I have to add up. I'm going to have 3 calcium. That's going to be 40 plus 40 plus 40. 2 phosphorus is going to be plus 31 plus 31. And then I'm going to have 8 oxygen, 16 times 8. And I'm going to get 310 grams Ca3PO4. I'm going to go off screen in 1 mole. So let me just write this out. When I multiply and divide that, I have that done. I'll grab my calculator. I get 0.806 moles. So over here, let's put 0.806 moles. So I'm starting with 3 moles of this, and I have 0.806 moles of this. And I want to know which one I'm going to run out of first. Well, we said in the last video, you have to do 2 calculations. 2 calculations. Well, I have 2 products here. So do I do calcium phosphate and sulfuric acid to calcium sulfate, or do I do them to this phosphoric? The answer is, it doesn't matter. You can pick either one. You can pick this, or you can pick this. This is the first product, so I'm just going to pick this. So for calculation number 1, I'm going to go from calcium phosphate to calcium sulfate. And for calculation number 2, I'm going to go from sulfuric acid to calcium sulfate. Okay, keep in mind that when we go mole, and we're going to solve, we can just solve for moles here. So let's frame this up. Number 1, I have so let's do calculation number 1. I have 0.806 moles of Ca3PO42. I'm going to put that over 1. And I'm going to solve for, again, I could do this is phosphoric acid. I could do that as easily, but I'm just going to go with moles of calcium sulfate. And in number 2, I've got 3 moles of sulfuric. I'm going to put that over 1, and I'm going to go to moles of calcium sulfate. Well, if I'm going to go mole to mole, I'm going to need mole ratio. And calcium phosphate to calcium sulfate has a 1 to 3 mole ratio. So I'm going to put 1 mole Ca3PO42 to the 3 moles of calcium sulfate. And down here, I have a 3 to 3 ratio. I have 3 moles of sulfuric to 3 moles. And again, in this case, we could simplify it. So I could simplify down to 1. So 3 times 1 is 3. 0.806, punch this in my calculator, is going to be 2.4. So look at this, and can you tell me which one is limiting and which one is excess? Hopefully you said that the calcium phosphate is going to be limiting because I'm going to only be able to make 2.4 moles of my product with this much. I'm going to have leftover sulfuric acid. So having a smaller amount of that calcium sulfate means that Ca3PO42 is going to be my limiting reactant. And it means that my sulfuric acid is going to be my excess. So what we're going to do in the next 2 videos is look at how we can use this to calculate amounts of product and to figure out how much of this we have left over. But that does it for 905, which is finding a limiting reactant, and we'll carry on in the next video.